Hello stats fans and welcome to section 3.3 of Matthew 15, where we are going to talk about percentiles and box-and-whisker plots. So if you recall, the median is the data point in the middle of an ordered set of data. So if you remember, we have to first put the numbers in order, right? Typically from smallest to largest, and then the one right in the middle is the median. And we talked about what to do if there's an even number of data points where there would be two in the middle. So the median is a data point in the middle of an ordered set of data, which means that 50% of the data fall at or below the median, and 50% of the data fall at or above the median. The median is an example of what's called a percentile, and the median is the 50th percentile. So let's take a look at these percentiles. The way they work is you'll have a whole number p, and p is between 1 and 99, right? So it's not 0, it's not 100. It could be 1 and it could be 99. The pth percentile of a distribution is a value such that p% of the data fall at or below it, and 100 minus p% of the data fall at or above it. So you've got at or below and at or above. So a couple of quick notes here. There's never 0 percentile, and there's never 100 percentile. So another note is there are several popular conventions for finding percentiles. This is not going to be important for us, just something to keep in mind. They result in slightly different answers. Mainly it's just because when you use a percentile, you have to break data up into 100 parts. And sometimes numbers fall on the line, so to say, as you're coming up with these lines to divide the numbers. So there's just different conventions. They're all fairly similar, but somewhat different. Not going to affect us. Mainly, we're using percentiles to set up the idea of quartiles. So we have to know what percentiles are, because you'll run across them in your life, especially with a standardized test, which we'll talk about in a minute. But really what we're heading for is quartiles. So the last note here is probably the most important one. And this is the one that gets confused. I'll just keep this one in red. These are not the same as percentages. So here's how they work. Let's say you score, just make a quick example here. We're going to write a little bit small. I should have probably left a little bit more room here, but let's just have this example. Let's say you score 80%. So you get 80% of the answers correct. You score 80% on a test. And the question is this good? Bad? Maybe just okay? Well, what percentiles can do is they can help you answer that. So as an example, what if everyone else who took the test, everyone else scored above 85%? Right? Well, then that score of 80% doesn't look good at all, right? If everyone else who took the test scored above 85%, assuming there's a decent amount of people taking the test. So percentiles show how you rank with your peers. I'll use red for this one. Percentiles show how you rank with your peers. So for instance, let's say, here's an example again. You score, let's say you score at the 83rd percentile on, let's say it's an ACT test. So as a reminder, this you'll run into percentiles on SAT, ACT, typically on national standardized tests. Some of you are going to an MBA program in college. You have to take the GMAT. If you go to law school, you'll take the LSAT. And grad school in general, you take the GRE test. So these are all tests that will report back your answer in percentiles. So if you score at the 83rd percentile on an ACT test, well, that's a good score, right? Because the 50th percentile is right in the middle. If you score in the 50th percentile, you pretty much did average. That means you scored at or above 50% of the students who took it and scored at or below the other 50%. So if you score at the 83rd percentile, it's very good because it means that you scored at or above 83% of the test takers. Again, sorry about not having too much room here. In the class, I write all over the whiteboard, so I have to make a little more room here next time. So if you scored the 83rd percentile on an ACT test, you scored at or above 83% of the test takers, and it also means you scored at or below, this is where this part comes in, this 100 minus P. So that means you scored at or below 17% of the test takers. Okay, so that's how percentiles work. That's what we have to know. We're not going to calculate percentiles, but we just have to know how to read them and what they mean. We need to know that if you score at the 70th percentile on some standardized test, that means you scored at or above 70% of the test takers and at or below 30% of the test takers. That's what we need to know about percentiles. And then really the reason we studied those is because we're going to talk about quartiles, which are just special percentiles that are often used. But instead of breaking the data into 100 parts, these are the percentiles that divide the data into 4 parts or fourths. So there'll be 3 like dividing lines. These are the 3 percentile marks that divide the data into 4 groups. So let's say we've got a bunch of numbers and we divide them in such a way that, let's say 25% of the data are in between these 2 points, 25% here. So we have these numbers we're going to divide. Think of taking 100 numbers, lining them up here. We're going to put 25% of them here, 25% here, 25% here, and 25% here. So it's not really like they're going to be perfectly lined up in a number line, but we're just going to divide them this way. So if there are 8 numbers spread out all over the place, we're putting 2 of them in this group, 2 of them here, 2 of them here, 2 of them here. So we're just dividing up all the data into 4 parts. And this number right here is going to be called the first quartile, or Q1. And then this one right here, this one right in the middle, we already know what that is. That's the median, right? That's the median there. And now the median is sometimes called the second quartile. So I'm going to put a Q2 here also, sometimes called the second quartile. And then this spot over here is called the third quartile, or Q3. So quartiles are a lot of times abbreviated with the symbols here. So this is Q, like a subscript 1, Q subscript 2 and so forth. So some other names that you'll hear though, let's see, the first quartile is sometimes called the 25th percentile. And of course the median could be called the 50th percentile. And then Q3 could be called the 75th percentile. Right, so if you score in the 75th percentile, you're way up here. That means that you scored at or above 75% of the test takers and at or below 25%. So out of all these names, I'm going to show you the ones that are most popular. Typically, people call this Q1, they call this the median, and they call this Q3. These are just some other names that are also correct, but just not as used as often. So if you have a bunch of numbers here, this Q1 median and Q3 are the numbers that divide them evenly into parts, so that 25% of the numbers will be here, 25% of them are here between these two, 25% of the numbers will be here between the median and the third quartile, and the upper 25% will be above the third quartile. Okay, so the little note here is that, again, there are several popular ways of doing this. We are going to use the same method as the TI-83 and 84, which is pretty standard, the most popular method. So we will use the same method as the Texas Instruments calculators do. Now, just as a little side note here, SAS, that statistics software program, uses 5 different methods, so you can pick which method you want. Most of them, they give similar results. There's just little differences about how to handle certain cases. But for us, essentially, this is what we're going to do. It's kind of the way that for most people makes the most sense. So here's what we're going to do. We're going to line up all the numbers. We're going to find the median. Then what we're going to do is find the median of the lower half. We're going to call that Q1. We're going to find the median of the upper half. Call that Q3. Okay, that's the most popular method, and that's one that we're going to use. So I know you guys are super excited about trying this, so let's try it out. How to compute quartiles. Well, there's a number of steps here. I can tell you that really, if you never looked at these steps, just based on what I told you about medians, you'd probably be able to do it. But basically, to compute these things, you order the data from smallest to largest, right? We have to do that to find the median. We find the median. Remember, that's the second quartile. The median is the second quartile. You can call it second quartile or median. Most people will use the term median. Then the first quartile, that is just the median of the lower half of the data. Right, the median of the lower half. And then the third quartile is just the median of the upper half. So basically, if you look at what we're going to do, we're going to find the median 3 times. So it's really, if you keep that in mind, it's a pretty simple process. So the first quartile is the median of the lower half of the data. The third quartile is the median of the upper half of the data. So the little note here, and it says, in the case of an odd number of data values, the median itself does not fall into either the lower or upper half of the data. This is another one of those things that if I had never told you this, you would probably do this anyway because it seems like the thing to do. But this will make sense when we try one. Now, I'll mention it when we try our first one, that the median, you've got an odd number of data values, the median doesn't fall into either the lower or the upper half, because with an odd number, the median is the one right in the middle, so the median neatly splits the data into 2 parts. So you'd have the lower part and the upper part. So that's for an odd number of data values. So if you have an even number of data values, well then The two values used to compute the median are included in the lower and upper halves of the data respectively. And again, you would probably do this even if you've never read this, because it just seems like the thing to do. And again, you'll know what I mean when we look at a couple of these. Okay, so we got one more thing that we need, and then there's the interquartile range. And our author says this is a popular measure of data spread utilizing relative position. I'm not really sure about that word popular. It is a measure of data spread utilizing relative position. I'm not sure it's all that popular, but it is pretty much always taught in a stats class. And this is Q3 minus Q1. Interquartile range is Q3, take away Q1. And if you remember, we talked about range before. If you remember, we talked about just plain old range. We just had range, and we said we're going to define range mathematically. Range is the largest number minus the smallest number. So range is an actual number, just like this. Interquartile range, we have to know that this is a number. The answer will be a number, right? So we're not using everyday speech for range, like the numbers range from 2 to 20. It's interquartile range is going to be whatever Q3 is, take away Q1, and it's a number that, it's just like the regular range. It gives an area of the spread of the data. So let's, to make sense of this, let's try a problem here. But before we try this one from the book, I just want to tell you, or show you one that talks about the even number and odd number of data points. So let's say we've got this really kind of simple example here. We want to find Q1, the median, and Q3. We know the median is the one right in the middle. So looking at this one, it's an odd number of data points. So since it's an odd number, we point right here, right? Here's the median. So in the notes above, it says if you've got an odd number of data points, then the median itself doesn't fall into either the lower or upper half of the data. And it makes sense because here's the median. Doesn't it neatly split the data into two parts with the same number of data points? So if there's an odd number of data points, you pick the median right in the middle, and then basically these right here, these numbers are the lower half of the data. These numbers are the upper half of the data. So then it's kind of easy to see, okay, the median of the lower half is 3, which means that 3 is going to be what we call Q1, first quartile. And same thing with the upper half of the data. There's this 9 right in the middle. So this 9 is going to be Q3, the third quartile. So I'm just going to throw another number on this pile. So what if we had 2, 3, 7, 8, 9, 9, 14, and 15? Same thing, they want us to find the median. So if we look over here, well, now we've got an even number of data points, right? So the median is going to have to be the mean of these two, right? So the median is going to be 8.5. Right, that's the median, because what we do is if there's an even number of data, we learned this from earlier when we talked about the measures of center. For an even number of data points, you add up the 2 in the middle and divide by 2. So here's our median. But also look what this does. This kind of divides the data right down the middle, right? So we've got lower half here, upper half here. So then Q1, well, this one's getting a little messy because now we have evens on both sides. So Q1 is going to be the average of these two, right? So 3 plus 7 is 10, divided by 2 is 5. So 5 is going to be Q1. And then over here, 9 plus 14 is 23. So 23 halves, or 11.5 will be Q3. Just remember, you guys, many of you do not like fractions, so we don't want to do 23 halves. Okay, so hopefully that makes sense of the couple of notes here about odd number data values and even number data values. And now let's just try this example from the book. So I'm just going to get rid of some of this stuff here to make a little room. And we'll do this example from the book. This example is number 6, A and B so far on page 129. So let's take a look at this one. Okay, so here are the data for number 6. We've got 2, 5, 5, 6, 7, 8, 8, 9, 10, and 12. So here's what you should do. Press pause a second and figure these out. I added the range. The book didn't ask about range, but I want to make sure we're clear on the range also. So we've got interquartile range and range. And Q1, Q3, low and high. So go ahead, figure it out, and come on back. Okay, so to find the median, look at the numbers here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So we're not going to have one right in the middle. So let's go to the 2 in the middle. It looks like the 2 in the middle are right here, 7 and 8. So what we would have to do, of course, is take the mean of these two, right? Add them up and divide by 2, and you'll get 7.5. So our median is 7.5, or 15 halves if you prefer. So that kind of divides us right here. So the data are divided right there. So we've got lower half. This is the lower half of the data, upper half of the data. So for the lower half of the data, to find Q1, we have to find the median here. And this has a number right in the middle, right? Here's number 5 right in the middle. That's going to be Q1. And then over here, we've also got one right in the middle. 9 is right in the middle. That's going to be Q3. So Q1 is 5. Q3 is 9. Okay, now the low. Low is exactly what it sounds like, the lowest number. That's 2, obviously. And the high is 12. So interquartile range. Remember, that's going to be Q3 take away Q1. Q3 take away Q1. 9 minus 5 is 4. Remember, it's a number. So if you're asked this question, don't say 5 to 9. That's not right. That's wrong. The interquartile range is Q3 take away Q1. And the range, remember, this is high take away low. 12 take away 2. The range is 10. So once we have this all calculated, we can talk about what's called the 5-number summary. And some of you, I'm sure, have heard of this from algebra classes. It's sometimes covered. It's the 5-number summary. I'll get started and see if you guys can fill in the rest. One of those numbers is the lowest value, Q1. The median, what do you think goes there? Q7, close, Q3. And then last one is highest value. So what we'll do with this 5-number summary is we're going to display it graphically as a box and whisker plot. So let's see what we can do with a box and whisker plot. So a box and whisker plot is a visual display of data spread about the median. And the note here is it can be vertical or horizontal. Whatever you want to do, totally up to you. So to get started, this one I'm going to make vertical. Again, it doesn't matter. You can do it either way. But with a box and whisker plot, we need a number line. So I'm going to make a vertical number line. And we need to cover the data. So if you look at the numbers we've got, they go from 2 to 12. So I'll just go from 0, I'll call this 12 up here, just because it makes it a little easier to number this. So put a 6 in the middle. So we got 2, 4, 6, 8, 10, and 12. Now with this number line, it's important to use equal spacing because we're going to show how the data are distributed and how they're spread out. So we really need this. So we don't want to do something like this. You know, this if you just kind of go, well, let's see, here's 0, 2, 4, 6, 10, 12. We don't want to do stuff like this. So it's not, you know, you look between here, well, here's 2 spaces, a little tiny gap. Then there's a giant gap for 2 spaces. So you defeat the purpose of even using this sort of graph because we're going to show how these data are distributed. So we have to have it equally spaced. And again, we're doing it by hand, so it's not going to be perfect, but it can be pretty good. So once you have this, here's how we display the data. We take our lowest point and we put a little dot about here. And the upper point, put a little dot about here. Some of you guys were taught to use lines here, short little lines, that's fine too. I'll do it like that at the end also. And then we had to show on here our Q1, our median, and Q3. So Q1 was at 5. So for this though, this is where the box part comes in. So we want to have a straight line coming across here. Well, as straight as you can make it. Hopefully yours are straighter than that. And then we have one at 7.5, right? Our median was 7.5. So here's about 7.5. And then we have our Q3, which was at 9. And then what we do is we connect these to make the box. And then we connect these whiskers. And we have something like this. If you've taken electronics classes before, you'll notice it looks a lot like a resistor. But that's what it looks like. Ours is fairly symmetrical, but they aren't always, so don't be surprised if when you make your box and whisker plot, it looks something like this. Okay, it's fairly common to have them really not symmetrical. So don't purposely put this in the middle. This is showing us that the lower 25% of the data are situated between 2 and 5, right? 25% of data. In this case, the lower 25% of data are really spread out. Now the next 25% are here between 5 and 7.5. And then the next 25% are sort of squished in here between 7.5 and 9. So the same amount of data points are in this group here as are in this group here. And in this, which is less symmetrical case, it's the same thing. The same amount of numbers are in this little area here. They're just squished together as are here, right? Because we're dividing our data into 4 parts. So that's why it's important to have this number, to have these equally spaced. Also, we definitely don't need to do this on when we have a number line, let's say our lowest data point is 40. We don't need to do this, right? Because this lower half, nobody cares about this. This is just starting at 40, so we don't need that on the end. So we don't need to show that there's space missing. We can just start at 40. Okay, so let's get rid of this. So we've got the numbers shown here. And now, of course, we need to label the axis, right? You've got an axis here. Notice also this is not connected to the drawing. Remember, there's a standard way to do things in math because it has to be understood by everyone on the planet. So we all learn, no matter where we're born and raised and languages we speak, we are taught to do this the same way so that we can communicate with one another. And of course, there'll be different variations, but we just want to stick to the very standard box and whisker plot in this case. We have to label, we have to say, what is this what is this 6 cats, $6, 6 weeks? We have to label this. Now in this case, we don't know what these are, but I want to label it so that we get used to always labeling it. So I'm just gonna say these are numbers. You know, this problem, number 6 is just made up. These don't correspond to anything, so normally this would mean something. We'd say what these are. These are like numbers of credits or something like that, so we put that here. And then we need a title also, so we could just call it problem 6 numbers. Problem number 6 numbers, because of course, again, this just made up. So this is how we would draw this box and whisker plot. So it's basically the 5-number summary displayed graphically, and it shows how the numbers are distributed. These numbers are fairly symmetric, right? They've got roughly the same size of the numbers being spread out. So they're a little squished. This 25% of data are a little squeezed together, but overall it's fairly consistent. We can't make our own format. So over the years I've been grading these kind of problems, and I just see these crazy box and whisker plots. Like there'll be a number line here. This would be connected somehow. You got these antennas out here. You got like X's in here or numbers like this. Just other things sticking out here. We can't make up our own format here, okay? It's got to look like this. There's a number line not touching, right? A standalone number line. And there's this thing that looks like a resistor. Like I said, there's one you guys may have learned to put these lines on here instead of the dots. That's fine too. That's probably 50-50 depending on which textbook you're using. But the key is we can't just make up our own. It's got to look something like this when we make these. So I think what we'll do, I'll just get a little more practice. We will we'll try this on the graphing calculator. So first I have to put the data in the calculator. So if you remember, go to the Stat button, Stat, and we hit Enter to go to Edit. There's already some things in here, so I go up arrow, Clear, Enter. The other way you can do it, I go up to there, hit Clear, and then down arrow. That also does it. And just need to put the data in here. So looking at this problem, the numbers were 2, 5, 5, 6, 7, 8, 8, 9, 10, and 12. So once the data are in there, let's go to the y equals, and I need to clear out anything in here. So I hit clear, clear, and see how this plot is highlighted? Let's just turn that off. So I go up to there and hit Enter, and that will turn it off. Okay, so we're gonna make a box and whisker plot. So we need to set our window. So let's go to the window key right here. Hit window, and we just need to cover the data. And our data go from 2 to 12. So just to make it simple, I'm just going to go 0 to 15. And I'll put a tick mark every 1 unit. The rest of this, the y values, you can just ignore. And the calculator will make it fit regardless of the y values. Now it may, if your y values are way off, it may not be able to correct for, but I'll show you how to make it work. So just ignore your y values. And then we go to, we want to go to the stat plot above the y equals. So you hit second y equals. And we need to turn this on. So to get to here, we just hit Enter. And now see how the off is highlighted? We need to hit Enter to make the on highlighted. And now the box and whisker plot, there's 2 of them here in the calculator. We want the second one. So go down to Type, then go over, and when I'm on this second one, I hit Enter. And then look what it does. X list is in list 1. So that's what we want. So now if I hit graph, it shows a box and whisker plot, and you can hit trace and then use your right and left arrows, and it'll show you, like, there's Q3, there's the median, and Q1, the minimum. So it gives us all these numbers that we just found, and the maximum. So if it's not displaying and you did everything correctly, here's what you can do. You can go to zoom, the zoom key, and go down to zoom stat, and then it should correct for the window. And most of the time you're gonna be fine, but if your Y value is way off, you can just hit enter and zoom stat, and then it should adjust the window so that it will work. And then again, you can hit the trace button to follow to see your points. Okay, so we don't really have to do this on the graphing calculator. Just wanted to show that it is capable of doing it, and just a little more practice putting data in the calculator. So speaking of the calculator, make sure you practice it. Practice with the calculator. Some of you have used them in the past, so you're all set. But if you're new to a graphing calculator, you definitely want to put some time in. It's really easy to figure out, but you have to put in a little bit of time to get familiar with it. There's also a couple of papers that I normally pass around to the class while we're working on this section. It's just a couple examples. One example is from quality control, where these box and whisker plots are used. And another example is from stock market analysis, where something very similar to a box and whisker plot is used. So here's the first example, and I'll just leave it here so you can take a look at it. And here is the other example, where you may see box and whisker plots used occasionally. And then I've got one more example. This is the effect my making videos has on my dog, who is obviously not very impressed. Hopefully you guys don't get this sleepy while you listen to these videos. But that's it for today, so make sure you try section 3.3 and let me know if you have any questions.